Have you ever pondered what the future holds for technology and artificial intelligence? As we sail swiftly into the era of digital transformation, the rapid advancements in AI and technology are nothing short of awe-inspiring. The potential for AI to revolutionize various sectors, from healthcare to finance, from education to entertainment, is indeed enormous. At the heart of these advancements is a fascinating concept known as convolutional neural networks. With an ability to analyze visual imagery, they are becoming a cornerstone of modern AI systems, laying the groundwork for the next wave of digital innovation. From autonomous vehicles navigating traffic to medical imaging technology spotting the tiniest irregularities, convolutional neural networks are becoming integral to our lives, often without us even realizing it. So what is this concept of convolutional neural networks, and how does it shape the future of AI? You may find the term convolutional neural networks intimidating, but fear not, it's simpler than it sounds. Let's break it down. Picture your brain, specifically the visual cortex, the part responsible for processing visual information. It's designed to recognize patterns, shapes, and objects, right? Now imagine a machine designed to do just that. That's essentially what a convolutional neural network, or CNN, is all about. Now, to get under the hood of a CNN, think of it as a series of filters. Just like you filter your coffee, a CNN filters information. But instead of separating coffee grounds from the liquid, it's separating and identifying patterns within images. It's these patterns that the CNN uses to understand and interpret the image as a whole. Think of it this way. When you look at a picture of a cat, your brain doesn't see just a random collection of pixels. It recognizes specific patterns: the triangular shape of the ears, the roundness of the eyes, the curve of the tail. These patterns come together to form the image of a cat in your mind. Similarly, a CNN breaks down an image into smaller parts, identifies the patterns in those parts, and then uses this information to understand the image as a whole. It starts by scanning the image for basic patterns, such as lines and edges. Then it gradually builds up to more complex patterns like shapes and textures. Finally, it combines these patterns to recognize the object in the image. The beauty of a CNN is that it can be trained. It can learn from experience just like us. Feed it enough images of cats, and it will become an expert at recognizing cats. It learns by adjusting its filters, fine-tuning them to recognize the patterns that matter. So, in essence, a convolutional neural network is a type of AI that excels at recognizing visual patterns. It's an incredible piece of technology that's already revolutionizing the way we interact with the digital world. And we're just scratching the surface. Now that we understand what a convolutional neural network is, let's delve into its structure. A convolutional neural network, or CNN for short, is a bit like an assembly line. Each layer of this network has a distinct role, and they all work together to recognize and interpret visual data. Let's start with the input layer. This is the very first stage of the process. It's where the network receives the raw pixel data of the image it's going to analyze. This data is just a bunch of numbers to you and me, but for the network, it's the starting point of an intricate journey. Next, we have the hidden layers. These are the real workhorses of a CNN. They include the convolutional layer, the pooling layer, and the fully connected layer. Each one of these layers has a unique role in the process of identifying features in an image. The convolutional layer is where the magic begins. It applies a set of filters to the input data, effectively scanning the image for specific features like edges, textures, or shapes. It's a bit like a detective searching for clues in a sea of pixels. Then comes the pooling layer. This layer's job is to simplify the information received from the convolutional layer. It does this by reducing the dimensionality of the data, while preserving the most important features. It's like a curator, deciding which pieces of information are worth keeping. The fully connected layer is where everything comes together. It takes the curated data from the pooling layer and uses it to make sense of the image as a whole. It's like a puzzle solver, putting the pieces together to see the bigger picture. Finally, we have the output layer. This is where the network makes its final decision. Based on the interpretation of the fully connected layer, it classifies the image into one of several categories. It's like a judge delivering the final verdict. Each layer of a convolutional neural network plays a crucial role in recognizing and interpreting visual data. You might wonder about the significance of convolutional neural networks. Let's explore their potential. Convolutional neural networks, often abbreviated as CNNs, have a multitude of applications that are revolutionizing the way we interact with the world. Like the silent heroes of artificial intelligence, they're working behind the scenes to make our lives easier, more efficient, and more fascinating. Take image and video recognition, for instance. Imagine a security system that can identify a criminal face in a crowd, or a social media application that can tag your friends in pictures with astonishing accuracy. This isn't science fiction, it's everyday reality, powered by CNNs. They recognize patterns, shapes, and objects in images, enabling machines to see and understand visual data in a way that was once only possible for humans. Let's shift gears and talk about self-driving cars. These modern marvels use CNNs to interpret a continuous stream of road and traffic data. Whether it's recognizing stop signs, detecting pedestrians, or understanding complex road scenarios, CNNs are the backbone of the decision-making process in autonomous vehicles. And it doesn't stop there. In the field of medical diagnostics, CNNs are making waves too. They're aiding doctors in detecting diseases earlier and with more precision. A CNN can scan thousands of medical images, learn to identify patterns of illness, and then alert doctors to potential health risks. This could mean early detection of a tumor or more accurate diagnosis of a rare disease, ultimately saving lives. But the power of CNNs extends beyond these applications. They're being used in natural language processing, weather forecasting, financial market analysis, and so much more. These neural networks are not just transforming technology, they're transforming our lives, our society, and the way we perceive the world. Indeed, convolutional neural networks are powerful tools impacting various sectors in ways we couldn't have imagined. With such potential, where are convolutional neural networks headed in the future? As we stand on the brink of a new era, the future of convolutional neural networks, or CNNs, appears brighter than ever. The advancements in this field promise to revolutionize the world as we know it, from healthcare to autonomous vehicles, from entertainment to security and beyond. One of the future possibilities for CNNs lies in the realm of real-time applications. Imagine a world where CNNs can process and analyze data in real time, making split-second decisions that could potentially save lives or optimize processes. This could have significant implications in various fields, such as emergency services or manufacturing. However, this journey into the future isn't without its challenges. Training these networks requires vast amounts of data and computational power. The risk of overfitting, where a model performs well on training data but poorly on new data, is a constant concern. Furthermore, the black box nature of these networks, where their internal workings are often incomprehensible to humans, raises questions about transparency and trust. But as with any challenge, these also present opportunities for advancement and innovation. New methods are being explored to reduce the amount of data and computational power required, such as transfer learning, where a pre-trained model is adapted for a new but similar task. In terms of transparency, research is being conducted to make these networks more interpretable, thereby increasing trust in their decisions. In conclusion, the future of convolutional neural networks is a fascinating landscape of possibilities, challenges, and solutions. It's an exciting journey that we are all a part of, whether we are directly involved in the field or simply beneficiaries of its advancements. Understanding and harnessing the power of CNNs is not just an academic exercise, but a crucial step towards shaping the future. It's a future where technology and AI work hand in hand to create a world that's smarter, safer, and more efficient. The future of convolutional neural networks is indeed promising, paving the way for a new era of AI and technology. As we stand on the brink of a technological revolution, it's crucial to understand the tools that are shaping our future. We've journeyed through the intricate world of convolutional neural networks, breaking them down, studying their anatomy, and marveling at their immense power. These networks, with their unique ability to analyze and interpret complex visual data, are not just tools, but the architects of our digital tomorrow. From recognizing faces in a crowd to diagnosing diseases from medical images, they're proving to be game changers. And as we've seen, their potential is far from tapped. In the realm of artificial intelligence, convolutional neural networks are standing in the spotlight, paving the way for technological advancements we can only begin to imagine. The future of AI and technology is a thrilling frontier, and convolutional neural networks are at the heart of it. As we move forward, let's embrace the power of convolutional neural networks and the potential they hold for our future.